Watch until the very end, because one of these black holes is so extreme it might not just destroy matter. It could be creating entirely new universes. Right now, somewhere far beyond our galaxy, a star is dying in the most violent way possible. Its core collapses under its own gravity, crushing inward at incredible speed. In a fraction of a second, it goes from something stable and shining to something completely unrecognizable. Gravity wins, space collapses, and a black hole is born. But not all black holes are equal. Some are relatively small, formed from the collapse of a single star. Others are so massive they sit at the center of galaxies, controlling the motion of billions of stars. And then there are the extremes, the ones that push the limits of physics itself. Let's start with something that already sounds impossible: a black hole known as TON 618. This is not just a big black hole. It is one of the largest ever discovered. Its mass is estimated to be around 66 billion times that of our Sun. To put that into perspective, if our entire solar system were placed inside it, everything would fit easily, with room to spare. What makes TON 618 even more extreme is not just its size, but how active it is. It's surrounded by a blazing disk of gas and dust spiraling inward at enormous speeds. This disk is so hot and energetic that it shines brighter than entire galaxies. From across billions of light years, astronomers can still detect its light. That means this single object is outshining hundreds of billions of stars combined. But here's where things get strange. As matter falls toward the black hole, time itself begins to slow down. From an outside perspective, anything approaching the edge appears to freeze, never quite crossing over. But from the perspective of that matter, it crosses the boundary in a finite amount of time and is gone forever. That boundary is called the event horizon, and once something crosses it, there is no return. Now, you might think something like TON 618 is rare, a once-in-a-universe anomaly. But the truth is, the universe is filled with supermassive black holes, many of them just as extreme in their own ways. At the center of our own galaxy lies Sagittarius A star. It's much smaller than TON 618, but still incredibly powerful, with a mass of about 4 million suns. Every star you see in the night sky, including our Sun, is orbiting this invisible giant. That means right now, as you're watching this, you are traveling through space around a black hole without even noticing it. A few years ago, scientists achieved something that once seemed impossible. They captured the first EVAR image of a black hole. The target was a supermassive black hole in a distant galaxy known as M87. The image showed a glowing ring surrounding a dark center, the shadow of the black hole itself. But the ring wasn't perfectly uniform. One side was brighter than the other. This wasn't an error. It was evidence that the black hole is spinning, and not just spinning slowly. It's rotating at a significant fraction of the speed of light. This rotation drags space itself around with it, an effect known as frame dragging. Imagine space as a fabric, and the black hole as a spinning object, twisting that fabric into a vortex. Anything nearby gets caught in that motion. Now, here's where it gets even more extreme. Some black holes don't just spin. They launch enormous jets of energy from their poles. These jets travel at nearly the speed of light and can extend for thousands, even millions of light years. They slice through entire galaxies, blasting radiation and particles across vast distances. These systems are known as quasars. A quasar forms when a supermassive black hole is feeding at an extreme rate. The energy released from the infalling matter creates a beacon so bright it can be seen across the observable universe. But the most mind-blowing part is that these jets don't come from inside the black hole. They originate from the region just outside the event horizon. That means somehow energy is being extracted from the edge of one of the most extreme environments in existence. Scientists are still working to fully understand how this process works, but it shows that black holes are not just cosmic vacuum cleaners. They are engines of incredible power. Now we're going to take a turn into something even more intense. There are events associated with black holes that release more energy in seconds than our Sun will produce over its entire lifetime. These are called gamma-ray bursts. They can occur when massive stars collapse into black holes or when neutron stars collide. For a brief moment, the universe lights up with a flash of energy so powerful it can be detected across billions of light years. If one of these bursts were to occur close to Earth, it could strip away our atmosphere and cause mass extinction. The only reason we're safe is because these events are incredibly rare and usually happen very far away. Now, let's go deeper into the unknown. Some scientists believe that not all black holes come from stars. There may be a type known as primordial black holes. These would have formed in the earliest moments of the universe, right after the Big Bang. Instead of being the result of collapsing stars, they would be formed from tiny fluctuations in the density of the early universe. These black holes could be incredibly small, even microscopic, yet still have significant mass. Others could be much larger, and here's the intriguing possibility. Some researchers think that these primordial black holes could make up a portion of dark matter, the mysterious substance that makes up most of the mass in the universe but cannot be directly observed. If that's true, then black holes are not just rare cosmic objects. They could be everywhere, silently shaping the structure of the universe. Now we reach the point where physics starts to break down. At the center of every black hole lies a singularity. This is a point where density becomes infinite, and the known laws of physics no longer apply. Space and time as we understand them cease to function normally. We don't know what happens at the singularity. Our current theories cannot describe it. This is one of the biggest unsolved problems in physics, but some ideas suggest something extraordinary. There is a possibility that black holes could be connected to other regions of space and time. In theory, they could form what are known as wormholes. These would act as shortcuts through the fabric of the universe, connecting distant points in space or even different universes altogether. The problem is that wormholes, if they exist, would likely be highly unstable. Any attempt to pass through one would probably result in destruction. Still, the idea remains one of the most fascinating possibilities in modern physics. We're about halfway through, and if you're finding this as mind-blowing as it sounds, now is the perfect moment to like the video. Subscribe to the channel and turn on the notification bell so you don't miss the next deep dive into the universe. Now let's talk about one of the strangest regions around a rotating black hole called the ergosphere. This is a zone just outside the event horizon where space is being dragged around so violently that nothing can remain stationary. In this region, it's theoretically possible to extract energy from the black hole. This concept is known as the Penrose process. It suggests that an advanced civilization could harness the rotational energy of a black hole as a nearly limitless power source. Instead of being purely destructive, black holes could become the ultimate engines of energy. But the extremes don't stop there. Astronomers have discovered black holes that existed when the universe was still very young. These objects are so massive that they challenge our understanding of how black holes grow. According to current models, there simply wasn't enough time for them to reach such enormous sizes. So how did they form? Did they grow at rates faster than we thought possible? Did they start off much larger than expected? Or is there something fundamental about black hole formation that we don't yet understand? These questions remain unanswered, pushing scientists to rethink their models of the early universe. And then there's the fact that black holes are not eternal. Over incredibly long timescales, they slowly lose mass through a process known as Hawking radiation. This occurs because of quantum effects near the event horizon, where particle pairs are created and one escapes while the other falls in. Over time, this leads to the gradual evaporation of the black hole. For stellar mass black holes, this process would take far longer than the current age of the universe, but eventually, they would disappear completely. What happens at the very end of this process is still unknown. Does the black hole vanish entirely? Does it leave behind some kind of remnant? Or does it release all the information it once contained? Now here's a final idea that might completely change how you see everything. Some theories suggest that black holes could give birth to new universes. Inside the event horizon, conditions might allow for the creation of a new expanding region of spacetime. If that's true, then every black hole could be the seed of another universe. And our own universe might exist inside a black hole from another, larger universe. Think about that for a moment. Everything you know, everything you've ever experienced, could be inside one of these objects. Before we wrap this up, I want you to drop a comment below and tell me which of these black holes fascinated you the most. Was it the gigantic Ton 618, the spinning monsters with energy jets, or the mysterious primordial black holes that could be hiding everywhere? And if you've made it this far, don't forget to like the video, subscribe, and hit the notification bell, because the universe has many more secrets waiting to be uncovered. Here's the real takeaway. Black holes are not just the end of matter. They are the edge of knowledge. They show us where our understanding fails and where new discoveries begin. The most extreme black holes push the limits of physics, challenge our assumptions, and hint at realities we are only beginning to imagine. Somewhere out there right now, one of these extreme black holes is bending space, warping time, and shaping the fate of entire galaxies. And the more we learn about them, the closer we get to understanding the true nature of the universe. And that might be the most extreme thing of all.